By the early part of the 20th century, the law looked after crews and passengers in a sanitary sense, with reasonable thoroughness. But although shipping companies were now required to exercise due diligence in providing proper sanitation, they had also discovered the advertising advantages of promoting the ingenuity and refinements of the luxury of the modern sanitary arrangements they could now provide. The result was that the great liners of Titanic's era lacked nothing that would be found in an up-to-date mansion or hotel on land. Titanic's sanitary fittings were surprisingly similar in appearance to those used ashore. First class had the best accommodations, of course, but by no means did the lower class suffer. Perhaps the biggest drawback to Olympic and Titanic's sanitary fittings was the relatively small number of private water closets and baths. Though bathing was not necessarily a daily activity for many people in 1912, the trip to the water closet on Titanic could sometimes involve a climb to another deck or walk to the opposite end of the ship. Titanic's sanitary outfit was supplied by well-known shipboard appliance manufacturers, the most prevalent of these being Royal Doulton and Shanks. Royal Doulton had also supplied other famous liners, including Mauretania, while Shanks' products were fitted aboard Lusitania and other ships. In 1846, Henry Doulton, son of the potter, introduced stoneware sanitation pipes to England. In 1847, the small factory at 63 High Street, Lambeth, was inundated with orders, and Doulton had to expand. The step up from stoneware pipes was water closets, and by 1899, the company was advertising itself as Doulton and Company of Lambeth, Paisley, and Paris. The royal name was conferred on Doulton in 1901, and the name Royal Doulton had been used ever since. The word royal was usually omitted from Doulton's sanitary ware, but the seal of the royal warrant was noticeably present. One could observe the words Doulton and Company Limited, Sanitary Engineers Works, London and Paisley applied beneath the glaze of their products. The company of Shanks of Barhead, Gaslow, through a remote and the main centers of activity in London, were nonetheless pioneers of the development of water closets. Shanks claimed to have solved the problem associated with symphonic water closets with the release of the Barhead Symphonic Closet in the 1890s. The company had an obsession with making improvements to flushing apparatus, and was the inventor of the push-button flush employed aboard many ships. A lavatory is a room with washing and toilet facilities. However, it is also a term used to describe a wash basin with a faucet and a drain. This term is still used today for wash basins in some areas of construction, but generally has been forgotten in the modern age, and the word sink is now the norm. Where the term lavatory is used in this text, the reference is to compartments containing both wash basins and toilets, the latter known more properly as a water closet, or WC. The English now use the slang term loo for a water closet, and the Americans use the term toilet. Although the term bathroom is also frequently used by Americans for a facility with a toilet, this term does not have the same meaning as the term bath in speaking of the facilities on board Titanic. A bath on Titanic was a room containing a bathtub, not a toilet or water closet. And when the bath was part of the private suite, such as those found in first class, it contained a wash basin as well. To avoid confusion in this text, the term bathroom has been used throughout. Although bath was the term used in specifications, passenger accommodations, plans, and period journals, it should be noted that none of Titanic's public shared bathrooms were fitted with lavatory basins. England was liberally endowed with spas for those at seaside. Bathing in seawater became a fashionable pursuit. This practice had its roots in the 18th century, and it was thought that salt water was therapeutic. This form of bathing was carried over onto passenger ships in the early part of the 20th century, although in most cases was the only option open to passengers. Advertisements were released by companies such as Vinolia Auto, boasting that their soap was supplied to the White Star Line for Olympic and Titanic. Special soap was provided to passengers for taking their saltwater baths, as regular soap did not tolerate the effects of seawater well. Only a limited number of first-class staterooms on Titanic had their own connecting bathrooms. Thus, more passengers had to use one of the public baths. If a passenger wished to take a bath in one of the public facilities, he would have to make a reservation first with the bedroom steward, who would pass it along to the bath steward. As these rooms were limited in number, the bath steward would run the water and announce to the passenger when the bath was ready. Second-class passengers had only public baths, although these were available on every deck where second-class accommodations were located. Third-class passengers were very limited in their access to bathing facilities, as there were only 2 bathrooms for them in the entire ship. Located on the after end of D-deck, there was 1 bathtub for men and 1 for ladies. Third-class passengers were, however, given pedestal water closets and ample wash basins of enameled iron fitted with slate counters. Fittings of enameled iron were finished first by heating the surface of the metal to a high temperature and then dusting it with an enamel powder. The heat melted the enamel on contact, resulting in a uniform coating. The piece was then fired at an even higher temperature to produce a smooth, hard porcelain-like surface permanently bonded to the metal. The bathrooms and lavatory rooms were enclosed within steel bulkheads, a departure from the wooden panels in the cabins and staterooms. In instances where public bathrooms were situated in blocks of 2 or 3, while the periphery of the block of baths was enclosed within full-height steel bulkheads. Internally, the baths were separated from one another by a wooden stile and panel partition resting upon a low steel coaming. The coaming, which was caulked watertight to the deck, planting into the steel bulkhead at either end, formed a separate basin beneath each bathroom, which prevented any spillage from seeping into the neighboring baths. The bulkheads were painted in white enamel, and the steel decking on the floor was covered with Portland cement, and then laid with encaustic tiles. White ceramic tiles with blue trim, as well as white tiles with green trim, had been recovered from the wreck. The manufacturer's marking of Villeroy and Boch indicates the possible origin as first class. These tiles would have been used in a lavatory or bath accommodations. The doorway openings to these facilities were given a low coaming to prevent incidents of overflowing water flooding into the other compartments. Miscellaneous fittings such as toilet paper holders, toilet bins, and sponge holders were provided by yet another company. But the sanitary ware manufacturers also sold sundries to accommodate their products. Toiletries such as toilet paper and sponges were supplied by outside manufacturers as well, and obtained through the White Star Line's Chandler Stonier of Liverpool. So getting into lavatories and wash basin fittings. Many of the Royal Dalton fittings on Titanic included wash basins of glazed porcelain or glazed earthenware, nickel-plated taps, and other hardware fittings to accompany their products. Wash basins manufactured by Shanks could be seen notably on private baths of the first-class suites, being wall-mounted in marble tops and black splashes with an iron bracket. Many first-class staterooms were provided with Dalton wash basins set in veined or St. Anne's marble upon wooden table stands fitted in the cabin below the paneled doors. These wash basin cabinets, sometimes referred to as the carcass, were fitted in the nickel-plated taps and hardware. The size of these wash basin cabinets varied depending on the size of the room and the assigned occupancy. Some of the basins had been raised from Titanic's wreck, and they bear the name Dalton seal even after decades of lying on the ocean floor. In many of the smaller staterooms on Titanic, the conservation of space was necessary. The fold-up wash basin cabinet, commonly called a compactum, wash basin cabinet commonly called a compactum or clock, was utilized. This was one of the very few pieces of furniture specifically designed for use aboard ship. Patterned after those used in railway cars, pictures indicate that Harlan and Wolff manufactured these wooden cabinets in their own joiner's shed. But commercial ones were available and can be seen in catalogs of sanitary ware manufacturers of the era. The wash basin and compactum was fitted inside a hinge flap. It was designed to be self-cleaned and to empty automatically when the basin was tipped up. Underneath the wash basin was a small cabinet containing a tank or a sluice bin, and was one of the same capacity as the wash basin so that it would hold the entire contents of the basin without overflowing. The fresh water supply was stored in a separate copper tank in the upper part of the compactum inside the cabinet-like housing concealed by a large mirror mounted to the front. This water supply tank was connected to the basin by a small pipe and tap, and the tank was filled through a small funnel entering the side of the upper housing. Shelves were commonly framed to the gables in the vicinity of the mirror to hold water bottles and glasses. When open, the basin was well out in front of the cabinet, and the tap was arranged to just be long enough to run the water into the basin. The taps were usually self-closing types. The basin was of glazed earthenware, set in white lead, and was screwed to the inside of the cabinets. Each basin had an anti-splash rim around its upper edge. In the lip, without the water would bore when it was tipped up and emptied. The tip-up basin and flap were supported horizontally by a stout piece of iron screwed to the same and by a knee piece screwed into the inside of the cabinet. However, brass quadrant stays were sometimes used for this purpose. As these fold-up wash basins cabinets were not connected to the ship's fresh water supply, they required water to be brought in manually by a steward who filled the concealed copper tank at the top. At the same time, the steward would empty the wastewater from the tank below. It was not uncommon for the folding covers and compactums to have two sections, the inside for the wash basin and the outer extension to act as a small table. A passenger could fold the wash basin up to its vertical position inside the cabinet, and the outer table section would remain horizontal. Usually, the width of the single cabinet was between 19 and 21 inches, while the double cabinets were generally 3 feet 3 inches to 3 feet 6 inches wide. Single basin cabinets were suitable or single for 2-berth cabins, but for 3 or 4-berth staterooms, a double basin cabinet was installed. A double basin cabinet had 2 wash basins, 2 sluice tanks, etc. In fact, from the basin down, it was similar to the 2 single wash basin cabinets placed side by side. Above the basins, its appearance differed. Its only one mirror was fitted. Although by nature utilitarian, these wash basin cabinets were well-designed pieces of furniture and were very compact and neatly arranged. The junior officers' quarters on the boat deck and the less expensive first-class staterooms, including those on E-deck, were provided with fold-up wash basin cabinets of a special modified design. In these cabinets, hot and cold water came from the ship's storage tanks and would feed pipes relayed direct to the basin. The sluice basin was then omitted, and the inside of the cabinet was configured to direct the water from the tipped-up basin directly onto the ship's soil pipes, where it was discharged overboard. Wash basin cabinets were made of the same wood as to the surrounding stateroom fittings. The gables were prepared to cut to shape, and the horizontal divisions were housed in them. A small door on the front were often solid and were strengthened by inserting a slip in the plow groove across the end wood. The door was large and was fitted with brass hinges. The bail catchers were generally fitted to hold the doors closed. Third-class passengers were provided with wash basin holders and tanks, but only in the accommodations for single women and married couples at the aft end of the ship. The rooms for single men were not equipped with these. The third-class wash basin holder was wall-mounted and had a metal tank with an approximate front dimension of 20 inches by 14 inches. The tank had one fitting hole in the center with a cup holder on each side near the top. These enameled tanks could be filled with hot or cold water and had a brass pipe running down into the glazed earthenware basin. The tank fed the basin through a pipe which was fitted with a self-closing push-button valve located on a midway through its length. The wastewater drained into the holding tank beneath the basin, from where it was emptied by a steward by opening a sluice valve at the bottom. The public lavatories and latrines for the passengers, what would be called today a public WC or restroom, were fitted with ranges of shanks, wash basins, and crew accommodations were similarly fitted. The first and second class passengers enjoyed a nickel-plated hardware and glazed earthenware basin contained within marble surroundings. Third class and crew accommodations were supplied with shanks, enameled iron basins fitted with slate surrounds and brass hardware. And in the lavatories for the general crew and in the latrines for third-class passengers, large enamel iron wash tubs were provided for washing clothes. The bathtubs for passengers were primarily manufactured by Dalton and were the rolled-up edge type, the long, parallel sides and plain rather than decorative feet. In appearance, they resembled large white troughs. The tubs were of cast iron, with enamel melted screen which partially enclosed the tub on three sides. All bathrooms were provided with folding wooden slat wall seats, rubber bath mats, as these were common fittings aboard ship. The floors were encaustic tiles, having electric heaters as well, a push bell within reach of every bather. Attendants cleansed the baths with disinfectant after use. The bathtub hardware and fittings in first and second class were nickel-plated to match those of the lavatory filaments. The hardware in the third class and crew accommodations were brass, all being supplied by the manufacturer of the tub. Water fill pipes for the bathtub were located at the bottoms of the tubs to eliminate the steam from hot water and to cut down on the noise associated with the top filling spigots. A tall wastewater cylinder accomplished draining of the bathtubs with a knob located on the top. This device was nothing fancy and quite straightforward in terms of the design. The design pipe from the bath was connected to a cylinder, and the same was connected into soil pipes. Inside a cylinder was a simple plug and socket arrangement, which connected to the knob on top via a rod. And when the knob was lifted, the plug disconnected from the cylinder, and the water was drained. Titanic's water closets were of the pedestal type. The term pedestal was first used in this context with pioneers like Thomas Twyford of Hanley invented the first all-earthenware washout water closets in the 1880s. Before this time, the water closet pan had to be supported on a large metal or wooden structure. Once the toilet became freestanding, in effect on its own, the term became applied to that of the type of water closet. White Star provided pedestal water closets and lever flushes for all passengers, including the third class, and for the crew. In the public lavatories and latrines on the lower decks, it was common to see a range of water closets. These were units situated in a line attached to a common soil pipe which was located above deck level. Each pan was fitted with an individual lever flush. Prior to the evolution of the great ocean liners, immigrants and crewmen had been generally provided with a multi-pan galvanized latrine trough that was constant flow of sanitary water running through them at all times. The provision of modern sanitary appliances aboard ship was not without its problems, however. Many immigrant passengers came from Central European countries where the sanitary facilities were very, very basic. On the R.M.S. Titanic, many of them were suddenly confronted with high technical water closets, and such they had never seen before. The immigrants had to be shown how to use such devices as the third-class stewards had to undertake this task. Many of the third-class passengers had never seen a bathroom in their lives either. They may have had an occasional bath in a tin tub in front of the fire on a Saturday night, but nothing to the extent of what was offered on a great ocean liner. Suddenly, they were confronted with a state-of-the-art flush toilets and enamel tubs with piped-in water. Harlan and Wolff shipbuilder Thomas Andrews, observing Olympic's first few voyages, despaired at the ignorance of the men and women in the immigrant class. And one of its projects became designing out all the little nooks and crannies in the third-class accommodation areas that were to be used in impromptu toilets. Apparently, some of the passengers wanted to urinate at night rather than walk the length of the corridor or climb a flight of stairs only to be confronted by a bewildering and unfamiliar contraptions that awaited them in the public latrines. Instead, they left their cabin, found the nearest dark little hole, did their business, and then went back to bed. The stewards had to mop and wash it all out the next morning. The third-class steward on Olympic would later recall that the times when seas were rough and seasickness compounded the trouble. The whole place became a disgusting mess. Water closets on shipboard consisted of generally two main types, single and double valve. The type of water closet installed in a ship depended greatly on where it was located on deck, the class of passenger, and the distance above or below the waterline. To prevent foul backdrafts, a single valve water closet had to have a siphon trap. It is a soil pipe, but a double valve fitment does not require this. Siphon traps were objectionable and a sharp double bend, liable to choke, and an air pipe had to be led from the upper elbow to prevent the trap from being emptied by suction. The water closet near below the waterline had to be emptied by a force pump, but these were rarely found outside of yachts. If wash basin, urinals, or baths discharged into an adjacent soil pipe, siphon traps and ventilating pipes had to be fitted to the discharge pipes to prevent foul backdrafts. However, backdrafts were not the only problem the shipboard water closets faced, and the manufacturers who supplied ships as Titanic designed out many of the common problems. For many years, valve closets were almost universal on board ship. They depended entirely on a discharge valve for keeping water in the basin, and when the valve got worn and leakage took place and the basin was left empty, it became foul with odor. The adoption of water closet basins with siphon traps and siphonic discharge overcame these difficulties. When the flushing valve was opened, the contents discharged by powerful suction. The basin was thoroughly cleansed by a flow of water and then refilled with clean water. Between the retention of a large area of water and in the basin and the deep water seal in the trap, the possibility of offensive odors was effectively prevented. Titanic's water closet basins were made of white glazed fire clay, the glazing being completely free of lead and able to withstand the action of acidic waste. The glaze used to create the shiny surface of sanitary products was very similar to the glaze used for tableware. The word leadless was usually seen somewhere on the surface for an interesting reason. Lead had been used in glaze for centuries, and it was this lead which gave the glaze a bright, attractive sheen. Unfortunately, lead is poisonous. In tableware, the lead is a glaze that could be leached out into foodstuffs by the acids contained in the food. Once the health effects became known, lead was banned from being used in glazing tableware. This practice was copied by the sanitary manufacturers, but for the safety of those workers in the plants, not the users of the product, leadless, however, was no doubt marked on the basins themselves to suggest that the product was somehow safer for the consumer. The flush mechanisms throughout Titanic were actuated by lifting a lever and depressing a valve within the mechanism, allowing the sanitary water to flow through and clear the pan. The mechanical linkage, which activated the flush mechanism, whether push button, lever action, handle pull, foot pedal, or door activated, seat activated, etc., were generally interchangeable. The form of flush manipulation was simply a matter of preference on the ship owner depending on the particular area in which the water closet was to be installed. Two of the aims when designing a ship's water supply system were reducing water waste and the elimination of concussion. Concussion, or water hammer, results when the flow of water under pressure is abruptly cut off as a result of a valve closing. The sudden interruption of flow sends a back pressure wave through the pipe, resulting in concussive jarring of the pipes. This is often experienced in older households when running the tap and suddenly shutting it off. Aboard ship, awkward bends were in some cases unavoidable in piping. Loud jars when valves were closed were not only objectionable to the passengers, but over time could cause considerable damage to the pipes and joints. Dalton and Shanks provided a valve that not only eliminated concussion entirely, but also prevented water waste. And some innovation was found in both the flushing valves of the water closets and the valves for the baths and lavatories. In each, the water pressure closed the valve, but instead, sharply cutting off the supply when released, it shut off slowly, and this time being adjusted by regulation screws, which in Titanic's case could be set for a maximum of 2 minutes. Each valve was entirely non-concussive, and there was not the slightest jar in any pipe after use. To operate the flush valve, the lever was raised, and this opened a relief valve, allowing the water under pressure above an internal plunger to escape through a port. The space above the plunger was in direct communication with the supply through an opening, which was fitted with the aforementioned screw to regulate the supply for the area above the plunger. The pressure being released in an area above the plunger allowed the supply pressure to act on it from below, raising it up off its seat. This allowed the water from the supply pipe to flow and flush the closet. When the valve closed, the space above the plunger then refilled with water under pressure, which acted against the top of the plunger, thereby closing the opening and stopping the flow of water to the closet. The rate in which the valve closed was regulated by the aforementioned screw, thus allowing any desired amount of water to pass through the closet and at the time preventing concussion. The water closets used in first class, both in private and public rooms, and in the alternate first and second class facilities were manufactured by Dalton to their Albion design. The basic Albion was model number 3000A, but other variations of this popular product were used, the difference generally being the type of flushing lever and the shape of the back of the pedestal to accommodate different piping variations. The 3000 series was of single valve trap design and was fitted with square storm or clack valves on the deck level to prevent the backflow of water from the system. The patent clack valve consisted of a hinge plate balanced by a weight. When the contents of the closet were discharged, the plate was deflected to a vertical position, thus leaving a perfectly clear outlet. When the discharge ceased, the attached counterweight raised the plate and closed the valve, and any back pressure closed the plate more tightly. The patent design obviated the necessity of bending the soil pipe into a horizontal position, which had to be done when the ordinary storm valve was used. The boxes containing the valves were fitted with metal covers to facilitate ease of repair. In fact, one of the distant advantages claimed for this arrangement was the fact that the connection of the pedestal, the waistline entirely above the deck. This eliminated the necessity to unship the pedestal from the deck for repairs to the valve replacement or the sealing rings. The Albion could be supplied with an anti-siphoning arm and attached to the flush valve if desired. These water closets were directly vented to the outside air as required by design. In fact, the big piece raised from Titanic's wreck has 2 vent pipes still attached to it, complete with storm valves, open air holes hidden among the rivets of SeaDeck. Shanks water closets were used in second and third class, crew facilities, and the engineers' accommodations. One of the Shanks water closet pedestals, raised from the wreck, measures approximately 19 inches in height and is one of Shanks double-valve Pacific models. Both valves are centered in a pedestal to economize on space. Being that it is double-valved, it is not internally trapped. The printing on the inside of the pan reads Shanks & Company Limited. This artifact was more likely from one of the crew's accommodations. The valves of this type of closet were arranged so that the outlet valve was always closed while the other one was open, effectively preventing backwash. An enclosed lever was located at the back and was fitted with an adjustable balance weight for a non-return valve on the outlet. The arrangement gave a definite control over the balance weight so that in the event of blockage, the lever could be operated by hand, thus clearing the obstruction. Normally, the non-return valve was closed and was automatically opened by the flush. All the water closets emptied into soil pipes, which were eventually drained straight out to the side of the ship just above the waterline. The salt water was continuously pumped through the system from the overflow of the sanitary water mains. Single-valve water closets had a trap molded within the pan assemblies, just like a modern toilet, requiring venting directly from the discharge of the unit. Double-valve water closets discharged into common soil pipes either above or below the deck levels. When the water closets in a public compartment were connected to a soil pipe above deck, they were commonly referred to as a range of water closets, as they were sold as one unit from the manufacturer. Trapping of the common soil pipe was accomplished at one of the ends, under deck level, along with a common ventilation pipe, which was attached to the top bend in the trap and led into a funnel casing or to the side of the ship. Soil pipe ventilation was never connected to fresh air ventilation trunks, which were completely separate circuits. Water closet stalls were partitioned off with wooden panels mounted to the deck with cast iron stools, and the doors fitted with round locking mechanisms which also acted as indicator handles, displaying either vacant or engaged. The exception to this was the stokehold crew in seamen's water closets, which were divided merely by a steel screen or slate. The electric lights in the water closet stalls were put on automatically by closing the door. When the door was closing, it pressed on a button fitted near the top hinge of the door, and a light would go on. The light going out immediately when the door was opened. For water closets, this was considered to be better than a switch, and many lights were left on when not required. Generally, each water closet was fitted with a mahogany seat and a raising lid, but satinwood and oak are also indicated in Olympic's 1935 auction book. It's interesting to note that in the 1920s and 30s, water closet manufacturers employed terms of French polishers to repolish mahogany toilet seats. These manufacturers made a lot of money from this process and will continue to as long as the ladies kept scratching up the seats with their suspenders. When it comes to urinals, adult urinals were installed within all the men's public lavatories, with the exception of the seaman and stokehold crew areas. These areas were fitted with urinal troughs. Urinals generally were one of 2 stall configurations, but 3 stalls were found in a few areas. The urinals were specifically designed to avoid ledges or the flat surface. Titanic did not have water closets below the waterline. Dives to the Britannic, however, have shown that she had Dalton transatlantic model hand pump water closets forward in one of the facilities for firemen or trimmers. These appear to have been located on C deck under the forecastle deck, a Britannic-only feature.